So this video works just number 10, and this is going to be, we're going to go through two different ways to solve this problem and a fairly long explanation. You can just watch the ways to solve the problem. Okay, for the function g defined above, a is a constant and g at 4 is 8. What is the value of g at negative 4? Okay, there's a sophisticated way to solve this, which is to realize that this is an even function. So this is a quadratic function. There's no linear or just plain x term here. So we've got a y-intercept of 24, and the function either goes up like that as a parabola or down like that as a parabola. So an even function is symmetrical about the y-axis. So if g at x equals 4 is 8, we go over here to 4, 8, then at negative 4, we will also be at y equals 8. So if we realize that, we can just go to choice A. We can check that for number 10. So choice A is correct. Okay, then there's what I call the brute force method. So the number inside the parentheses in function notation is our independent value, or x value. This is the y. So we can say 8 equals a times 4 squared plus 24. We can subtract 24 from both sides and get 16. Then 4 squared is 16, so 16a equals negative 16, where a equals negative 1. So here's our actual function. G of x equals the negative of x squared plus 24. If we substitute in an x value of negative 4, we get the negative of negative 4 squared plus 24. Negative 4 squared is 16, but we have a negative in front of it. And 24 minus 16 is 8. So we're back to that same answer, which is correct. I'm going to go on to an explanation of even functions, odd functions, and neither even nor odd functions. So you can skip this if all you're worrying about is preparing for SAT. So I've started a new problem, problem 8. I'm in a calculator page. I'm going to put in the number 1 and then go Control STOW, which stands for store, and store that number 1 in A. If I look at my vars, I got one variable stored there, A. I'm now going to go Control Doc for plus page, add a calculator page, and I'm going to put in that function from the SAT problem. And if I do a letter times a letter, I need to put in a times sign. The calculator will not recognize implied multiplication in that case. So a times x squared plus 24. I'm going to hit enter, and I don't see anything. Not really a problem. I just need to adjust my window. I like negative 10 to 10 for my x, but I am going to change the scale to 1. So there's going to be a tick mark every 1. I'm going to change my y to negative 50 to 50 and put 20% of that range in as a tick mark. So I've got an upward facing parabola, and I am symmetrical about the y-axis. So if I go to menu, trace, 1 for graph trace, and I go over to positive 4 and hit enter, then I've got 440. If I go over at negative 4, because we're symmetrical about the y-axis, that's negative 4 is also going to be 40. And then I'm going to go back to the calculator page and put in negative 1, then store that in A. And if I go back to my graph, then those 2 points are 4, 8 and negative 4, 8. So because we had a even function, f at 4 is going to be 8, f at negative 4 is going to be 8, because that's symmetry about the y-axis. Now, an odd function is symmetrical about the origin. So I'm going to put in an odd function, y equals x cubed. And you may not be able to tell that it's obvious that it's symmetrical about the origin, but we're going to trace again. Menu, trace, graph trace. And right now I'm on the parabola, which is the blue function. If I want to move between functions, I can up or down arrow. So I'm going to put in -2, enter. If I hit enter again, I've put a point there and labeled the point. Now I'm going to go to +2, and I've got 2, 8. I'm going to hit escape to get rid of the cursors, and without the icon up here telling me I'm in the trace mode, I can move these labels where I like them. I'm now going to take a picture of this and put a line between the 2 points. And I just want a solid line. So if I go try to get the center there to the center, so that line goes through the origin, and that tells me that I'm symmetrical about the origin. So the thing with the odd function is if I say f at x is going to be equal to the negative of f at -x. So what does that mean? F at 2 equals 8, which is going to be the negative of f at 2 to f at x, which is, and that, well, f at -2 is going to be equal to the negative of f at 2, which is -8. So if we knew we had an odd function and it said f at 2 equals 8, we'd know that f at -2 equals -8. And then if I just have integers, if a number is not even, it's got to be odd. If a number is not odd, it's got to be even. That is not true for functions. So I can take an even function and ruin its evenness by moving it left to right. So I'm going to do that right now. Tab up to my original function, and I'm going to put in a x term. So I'm going to say plus, say 8x, and plus 24. And I moved that to the right, and I think it moved it up a little bit too, but now I am no longer symmetrical about the y-axis, and this is a neither odd nor even function. To ruin oddness for a function, I move it up or down. So I'm going to take the f2 of x and say plus 10. So I've moved it up, and I can connect these two points, and I'm no longer going through the origin. So I've ruined the oddness. Now I have a neither function. And that concludes this video.